Johnny, last week we recorded the Clash of Code. And I mean, I'm not saying it was frustrating, but let's say we got really non-exciting problems. Is that fair to say?
Yeah, it's like summing up some numbers.
Yes.
I'm glad because I'm not that advanced either, but you could go much deeper and have to get problems that you have to think a lot more about.
Yes. And I'm not sure if they change the algorithm where now you have to level up to have interesting problems. But anyway, we did, so how many? We did 3, 6, like dozen problems, and they were all kind of boring. Actually, one of them, which we showed on the video, someone pointed in the comments that you can do it in O1 instead of, and you received, I think you sent me, like you received in a private message, or was it social media? Or
Yeah.
DM?
Somebody sent me in private and sent me like a really creative solution of how this problem could be solved even more elegantly.
And this was very cool. And this is going to play in what I want to show you today. So this was pretty boring. How do we make it exciting?
Okay, tell me.
You know how we make it exciting.
We make it more exciting by...
So these boring problems, if we do it in TypeScript only, then
okay, of course.
Then they get really interesting. And so people who have commented about the O1 solution, I have to thank them also a lot. So I went back to the footage and I took a screenshot here for every problems we have. And here they are sorted. So this one, reorder. So basically there are two categories. Either they need to do some string manipulation, or they need to do some arithmetic. At some point we had to convert Fahrenheit to Celsius and so on. So reorder needs, it's mostly string manipulation, but we need a tiny bit of arithmetic. These reverse, wrap, word count, draw are only string manipulation, and these are arithmetic.
I'm struggling on the first one for sure, but I'm looking forward to see your magic now.
So for the arithmetic ones, if we know how to count, we know how to increment and we know how to decrement. And if we know how to increment and decrement, we can add, we can subtract. And if we can add and subtract, we can multiply and divide. If we can multiply, divide, add, and subtract, we can modulo. And if we can do these operations, all the ones which are in the category arithmetic are easy to solve. And because then we have the same,
Yeah, you just have to implement multiply and divide yourself.
Exactly.
But yeah.
Which is so cool.
No biggie, as long as it's TypeScript.
But isn't that cool that we get to re-implement, so something that we take as granted as add, that we get to re-implement it from scratch. I think it's such a privilege. It's such also an educational, because how does your chip implement adds and subtract, and probably not like really. I'm gonna do, but
and yeah, it's compiled to 0 bytes, so really fast. And yeah, I forgot about this, that that like multiply is just like you can add together and then it's like multiplied, and that you can also implement divide using just
subtraction,
addition and subtraction.
Yes. But you know everything already.
Yeah. It's also high level now that you forget it's all zeros and ones.
Yes, perfect. So before we get into the counting, let's warm up. Let's warm up with the simple problems.
Sounds good.
So one of the most simple problem we had was inverting the binary string.
Makes sense. Okay, so converting zeros to 1 and 1s to 0.
So let me write yes. So we had I mean, I don't even need to write the reference result, but so we have as a result of, so let's call it invert of, I don't know, what was it? 0, 0, 1. We should get 1, 1, 0, right?
Yes.
So far, so good. So let's define invert.
So I guess we have to loop over
So we get a string.
each character.
Yes. So let's get the first character. And so we're going to do e extends a string. We infer the first character, the head, and then we have the tail.
Interesting invert keyword.
If
don't see that very often.
If we can invert, why do I get? Okay, that's good. If we cannot infer, we can return the result. So I'm gonna store the result, and the default value of the result is empty string. And here, we just have to call invert on the tail, so on the remaining. And we need to concatenate to the result. So here we have a result, we concatenate. So if head is 1, we add 0 and vice versa. So head, head extends 1, we return 0. If not 1. And here I should put extends a string. So nicely inverted.
Wow, okay, that was not too hard actually.
No, it's quite elegant. So that was the first challenge.
Just getting warmed up.
We're getting warmed up.
Okay.
Let's go. I mean, so this one also is somewhat, I think, easy. The word wrapping. Let's see.
All right.
Hello. Here, if we can replace every character by a star, we're golden, basically. The job is done.
That's right. Okay.
So here, can I just replace this one? Oh, sorry. Wrap. And so maybe I can just replace, just put a star instead.
Interesting.
Oops, sorry.
So you can have a multi-line type literal.
Yeah, so here we have the hello world.
Okay, that was easy.
And then we can just concatenate. So let me see. So let's call it wrap line. So this one is wrap line. And here we can just do wrap is a concatenation of 3 lines, right? So, and then we do a return line. We have the wrap with the, oh no, then we have the, okay.
It looks recursive. I'm not sure if this
No, sorry, yeah, it's wrap line. Nice catch. Return line. And then we have, here we have a star, a space, the word. So here we have, let's call it, I don't know, input. So here we have the input, space, and then a return line. And we type. And I guess this one needs to extend a string.
All right.
And here,
yes,
to wrap line, we need to add on each side, I guess, 2 stars, right? But it's almost as easy as doing it in JavaScript.
Man, if you did this during the challenge, just like write the perfect solution in TypeScript, and I was here also doing it in TypeScript, but in the other way of TypeScript, and you would completely destroyed me.
So we're warming up nicely. Nice word count. How hard can it be?
Okay, so we split by space, and then we
Yeah, so here we had the space here, right? So let me just remove this guy. Here the result is not a string but a count, a number, or let's make it an array.
Okay, and this one is I think a bit harder though.
So extend an array of 0 and default value is empty array. So here we put a space, right? So we want the word. And so here we do word count on the tail. If not, we return the result, the length of the array. But actually, after I'm going to show you how to do +1 and so on. So we could use it here, but here, let's say we don't know about these things. So here we return the length of the array, and here we increment the array by 1. So we add 1, 0 to the result. No. Why? Because, let me think.
Maybe you need to do +1? Maybe now it's 2?
Yes, but why? Why do we need to do +1? Because if you have only one word, this is not inferred. So length is 0, yes. So I could do default value is. So here we should have 3.
Okay.
So far, so good.
Oh, it's
It's easy.
you are faster than you're almost as fast as like in the actual challenges.
Yes.
Where people would use like this would be faster than writing it in Objective-C, to be honest.
But it's funny because you know how slow I got to solve the problems, and yeah, I'm actually being much faster.
Now you're faster in types.
What can I say? I'm much comfortable with types. And
Wow.
so, you know, when we did it 2 weeks ago, I was with this runtime stuff. I was like, you know, I was so slow, but now it's fast.
It's your destiny to just, never touch the runtime again.
No, I should never touch the runtime again. That's, but you're joking, but actually.
But actually, yes.
Yes. Because I'm working on a project where I'm really like I feel like I can help so much by not touching the runtime and really making things stricter and removing technical debt only by touching the TypeScript. But anyways, I'm digressing.
Can you please re-implement the SVG rendering on Android just using types? Because we need to make that a bit faster.
So you are joking, but...
But
bro,
actually...
you are
No.
I'm going to show you something. You are... So I'm going to prepare something for next week. Well, maybe we can use like stars to rasterize pixels. No, but we can really like, I'm sure we can draw lines and stuff like that. Because let me show you something which I think you're going to be very surprised. Do you know about this project?
TSSQL. And oh my God.
Full-fledged SQL parser implementing in types only. Look, you have data here. You have complex SQL queries, and the result is executed at the compile time.
Has TypeScript gone too far? I think it's getting too unreal.
No, but so if you can do this, I believe you can rasterize in TypeScript.
Yeah, makes sense actually.
But it's not crazy. Yeah, right. I mean, come on. Compile time.
It's
But I think TypeScript hasn't gone far. It needs to go even further.
Yes, it needs to go to the Mars.
It needs to go beyond the moon, because even like I was thinking, so the add, multiply, and so on. I think there are some genuine use cases like besides us, like to have built-in support for it. I think there's genuine use cases where actually it makes sense. And even like if you take the simplest thing where you would have like a number, let's say 3,600, and just for the fact that you could write it in TypeScript, as being like, for instance, the multiplication between, it's like 60 times 60 or something. And it makes it clearer because you say, oh, we multiplied, I don't know, hours by seconds or whatever. Just to make the code clearer, I think it would be helpful. And then also to do, I don't know, types which make Fahrenheit to Celsius. I don't know, but I'm disgracing. But so, okay, we challenge accepted, Johnny. I'll see you next week. So what were we doing? The drawing. So we had hello world. No, we had draw and we had free. So you remember this one, right? So if you had three lines, I mean, I guess now it's pretty clear how we would do it, right? Based on...
Mm-hmm. So it needs to be 2-dimensional.
Yes, so let's do one line first, right? So let's call it draw line. Here, the result is a string. Yeah. Number, so we need a state, which is an array we increase in size every time. So as always, we stop if, but I think now.
Are you going to do like a for loop with 2 iterations or
something like this? But actually, I think there's probably a much more efficient way to do it. But let me check.
Yes, even if you don't have any runtime, you can still optimize the compile time.
I mean, here you really need to, because there are some limitations on the stack size that is created at compile time and things like this. So slength extends I, we're done, and we return the result. And if not, so here let me just do extends, let's say zeros or whatever. If not, we draw the line, result we concatenate. So okay, input is the same, state we add 1 0. So to state we add 1 0. And here we concatenate the star. So to R we concatenate the star. So we draw on the line and we need to do this 3 times.
Makes sense. So
draw.
I see. So now you just
so here it's the same.
I see. So it's not quite recursive.
But here instead of a star, it's a draw line.
It's a new line.
Plus a new line. New line and draw line of I. Oops. We have some issue. Yes, so here you see it worked. So this excessive stack comparison I think can be fixed. When we did the video with the React implemented in TypeScript, we had also this error and this one was fixable. And someone pointed out in the comments, oh, but I have this excessive stack deep comparing, and then I could rewrite it in a cleaner way. I think here it's possible, but okay, let's...
Yeah, I mean, it says excessive, but they don't know your ambitions.
Yes, it's more than excessive. Here we had to do min.
Come on, easy.
Easy, right?
If I mean, I still want you to do it, but if one number is smaller than the other, then that's the one. Otherwise, it's the other one.
But how do you do less than?
Oh, You need to. Oh, you subtract and then.
That's definitely one way to do it. So if we add these arithmetic operators, which we're going to have, then you subtract, you can look, and then that's correct. But let's say we don't have access to these, we just count, and if we get to A, we return A. If we get to B, we return B.
Oh, yeah, that's smart.
But indeed, all these things, they rely on simple arithmetic operators. And so maybe we should start by building them, but let's do this one quickly. So min AB, and so we're going to count. So we're going to have a counter here, which is an array of, let's say, zeros. And default value is empty. Sorry. So if C length extends A, it means we should stop, and the minimum is A. We reached to A. If not, we check if we reach B, and then we need to return B. So extends B, we return B. If not, we continue. So we do a min of A, B, and we add 1, 0 to the array.
All right, pretty good. And I mean, the fact that it's kind of recursive, and you know, if like the numbers were like 100,005, we can just not worry about, because at the runtime it's still 0.
Yeah, that's right. Yeah, bundle size 0, execution time 0.
Amazing.
How do you do the max?
I would just maybe count down from infinity. No, that doesn't work.
No, it's simply here, if it's A equals A, you return B, and if it's B, you return A.
Oh, wow.
No, yes, that's trick question.
Amazing.
So that's max. But let's go into arithmetics. To solve any of the further problems, we need some primitives. And we need to learn how to count first. The first thing we need to do. Before doing any operations, before doing plus, minus, we need to count, learn how to count. We're like a baby, right? We don't know even how to count.
Yes, I think in school I also first learned 2 comes after 1 and 3 comes after 2 before
doing 2 plus 2.
Yes.
So let's do it like we learned baby steps. So let's learn how to count. So let's learn how to count at 5 or whatever. So, but this now you have a pretty good intuition on how we count. So A, and then state, I mean, it's always the same. Let's say extends array of zeros, default value zeros. And so if A, so here it's pretty repetitive because we use this technique all the time, but trust me, it's gonna be worth it. What comes next is quite cool.
Yes, baby steps. We have
baby
to do
steps.
It in the right order.
Yes, so
you cannot skip learning how to count.
Exactly.
Before you do more, before you do arithmetics. Okay.
Yes.
Makes
sense. So here we return S, and if not, we count. And we increment by 1. Okay. So now, before we can add, let's learn how to increment and decrement.
Okay. Yeah.
So let's do inc 5. Because
incrementing is basically, it's also some sort of addition. It's always just plus 1.
Yes.
So it seems like a primitive that makes sense to implement.
Yes. So increment is we take the count to A and we add one element. So count to A.
Okay, so we have 6 now. Okay, yeah.
Right? I mean, you can even do length, right? Yeah, I mean. Okay.
Checks out.
Checks out. Now,
how do we decrement?
I mean, let me actually maybe even put length here. So how do we decrement? You know, if you look deep in your heart, you know how to decrement.
So
we used.
It's the inverse of increment. So
no, it's
not.
No, it's done using head tail like we did before.
I see. Okay. So do we use the infer keyword again, or is that?
Yes.
Or do we? I see.
So if count to A extends infer head infer tail, sorry, and here maybe I don't know, we return we can return the tail length.
I see.
If not 0. No.
But you did use the increment, yeah. Okay.
Yes.
Okay. Wow. I understand an example with the infer keyword now.
Yes, I've seen, like I feel like I also barely scratch the surface with infer because I've seen such crazy complex examples. But okay, so we know how to do +1, we know how to do -1. Now we are ready to
go to the moon.
No, to do, let's say, 3 + 5. So add AB.
Okay, so now we recursively call increment 3 times, I suppose.
Yeah, so
I mean, easier said than done.
If B, so we're going to decrement B every time and add to A. And as soon B equals 0, we return A, which is the result. And if not, we add to inc A, decrement B.
Oh, that's
8.
Wow. You have to get a bit creative with these solutions.
That's why it's so addictive. I'm addicted.
I get you now.
And that's why also I think I love also it's so educational, and that's why I think also I really love, I mean, there's so many reasons I love the reanimated one, but we had this crude primitive and we had to rebuild the world with it. And it's cool because then you learn about Bezier and you have to implement these things yourselves. And it's cool because when you use a fancy tool, you don't get to learn the basics behind. And that's what I really appreciate about these things.
Absolutely. I mean, even if in here it's for fun, we can surely apply this to like real world examples. Or like yes. It helps us like find always the right technique in real world examples.
And the fun value is to the moon here. And in fact, if we go back to I saw something cool because then I went into issues. And then is there a practical reason for doing this?
Okay.
And then I guess it's the author, I'm not sure. And then he pointed out to this meme.
Why is it important that we have trapped antimatter?
Yeah, because it's fucking awesome. So let's do subtraction.
That's the right mentality. And I think subtraction should be just like, yeah, it should be pretty similar, right?
decrease.
Except we increment B and decrement A maybe?
So we decrement A. And when B, and we decrement B, and when B equals 0, we return A.
I see, yes.
Yeah.
All right. Baby steps.
Baby steps.
Now we can add and subtract. Now we already go to the second grade.
Yes. Let's multiply. So multiply, we're going to add A every time to the intermediary result. So we need an intermediary result. And to the result, so when B equals 0, so here A we keep. We decrement B every time. And here we return the result. And the result, every time we do one pass, we add to the result A. So at the beginning, it's, and here default value is 0. So it's A plus A plus A plus A, and that's how we multiply, I think.
Interesting. Yeah, now you passed 3 arguments. Okay. Now scanning there. Oh, but you don't have add defined anymore.
Oh.
Yeah, we deleted that.
Let's build it back here. So add, we said inc here. I think it's correct, right? We add every yeah, it should be good. Yeah, we have a bug here. It's not in add, it's sub.
Oh,
so we have to be
that
careful.
Makes sense.
15.
Wow. Okay. I thought maybe I know what's wrong, but no.
Oh man.
No, division. I mean, that sounds really complicated. Now it can become like a floating point.
Oh, you're gonna love this. Don't get me starting. Oh, you're gonna love this one.
Can you do 0.1 plus 0.2 and get 0.3000004?
I like where your head is at.
That's the only correct solution.
So let's divide. So let's do a non-Euclidean division, and then we'll show you a Euclidean division. So let's do an easy one. So 10 divided, and then we look into more complex cases. So 10 divided by 2. How do we do it? So we need to increment a result by 1 every time. So increment R. And B we need to keep. The divider needs to be always the same. We check if A extends 0, if we are done, and to A we remove B. I think. I don't know, I have no idea. Like just intuitively, no. Sub A, B. Oh, it's not multiply, it's divide, yeah. Okay, 5.
Okay, wow.
Pretty straightforward,
Well
yeah.
Yeah, super straightforward.
So now let's do Euclidean division. So let's call this one, I don't know. That's a great name, div1. Now let's do the
okay, so
real
this
div.
only works if it's like evenly
Exactly.
dividable.
Yes. Now let's do 10, let's say 70 divided by 10. So here it says
2.
No, wait.
Which is
wrong. It should be 1. It's 1 plus modulo 7.
Well, it should be 1
and reminder 7.
It's not, which is closer to 0.
But what I want is 1, and I want modulo equals 7. That's what I want.
Okay.
But yeah, fair enough.
It's open for
interpretation.
Yes.
I mean, yes and no, but okay, we. So let's do divide AB, and now we can do what do we do? So if div1 a b extends the extends. So if we multiply this one by a, so multiply a by the division, if it's equals to the multiplication of ab, we know it's like 5 divided by like 10 divided by 5. The remaining is 0. And if the remaining is 0, we can return the result. If not, we decrement by 1.
Okay, that makes sense. So
it's going to be important to be able to get the modulo. But let's see.
Yeah, I was just thinking, what if the remainder is never 0? But if we then always go into a routine where we subtract 1 by 1, then at least for integers, it sounds possible.
Multiplication, so it's by b here. Yes. Okay, let me. So b times the divider here should be equals to a. And yes. So here now we have 1. If
nice.
I do. That's good. This enables us to do the modulo now. Modulo AB. So the modulo AB is we subtract to A divided by B. No, multiply with this thing here. Right? Okay, it's okay. 0, 7.
All right. Well, no.
So
well, it was right for 20. Did you mean to use diff instead of diff1?
Oh, damn it. That's correct.
Yes.
All right.
I helped somehow.
Cool, huh? We learned how to count, we learned how to do. And now we can go to the moon and we can do. I mean, let's take a break, but now it's pretty clear that, I mean, you've done the challenges, it's pretty clear that now with these primitives we can finish the job.
Absolutely. I mean, I don't know what to say. We've set a foundation, and it seems like you have plans to take over the world now. And I will be here by your side to see you do it.
And the funny thing is that, so today we got 2 things we wanted to talk about, we are pretty excited about, and we'll have to follow up on both things because these are such exciting topics.
Absolutely. It's only going to get better from now.